Ever wondered why a piece of iron rusts or why a cake rises in the oven? Well, both are examples of chemical reactions taking place. These fascinating processes are happening all around us, and not just in laboratories. From the food we eat to the air we breathe, chemical reactions are a vital part of our everyday lives. By understanding these reactions, we can better comprehend and even manipulate the world around us. So how can we tell if a chemical reaction has occurred? Let's find out. What are the telltale signs of a chemical reaction? It's not always as dramatic as an explosion or a color change. Let's delve into the 5 key signs that indicate a chemical reaction has occurred. First, we have a color change, like when an apple turns brown after being cut open. This is due to a reaction between the apple's enzymes and oxygen in the air. Next, we have gas production. Ever noticed the bubbles when you pour vinegar on baking soda? That's carbon dioxide gas being produced from a chemical reaction. Thirdly, there's the formation of a precipitate. This is when 2 liquids react and a solid forms, settling at the bottom. Fourth, a change in temperature. For instance, hand warmers heat up due to an exothermic chemical reaction. Lastly, a change in properties, like when you bake dough into bread. It's still flour, water and yeast, but with entirely different properties. Next, we will explore the hierarchy in chemical reactions involving metals, also known as the activity series of metals. Did you know metals too have a pecking order when it comes to reacting with other elements? This hierarchy is known as the activity series of metals. It's like a leaderboard where the most reactive metals sit at the top, always ready to react, while the less reactive ones are at the bottom, taking it easy. Picture this: you're at a party and there's a dance-off. The metals higher up in the series, like potassium and sodium, are the life of the party. They're quick to react, always ready to dance off with any partner. But metals like gold and platinum, they're the wallflowers, lower in the series, less reactive and not so keen on joining the dance. This hierarchy matters because a metal high up in the series can replace a metal lower down during a chemical reaction. It's like the better dancer stealing the show. Now that we know about the activity series, let's dive into the rules for counting atoms in a chemical reaction. Ever played the game of balance? It's quite similar when we talk about balancing chemical equations. You see, the law of conservation of mass is the guiding principle here. It asserts that mass can neither be created nor destroyed. In the context of a chemical reaction, it means the total mass of the reactants must equal the total mass of the products. So, how does this relate to counting atoms? Well, the number of atoms of each element must be the same on both sides of the equation, ensuring mass conservation. Let's take a simple chemical equation as an example. Hydrogen gas reacts with oxygen gas to form water. In its unbalanced form, it reads H2 plus O2 equals H2O. But hold on, we have 2 oxygen atoms on the left and only 1 on the right. To balance it, we need to adjust the coefficients, not the subscripts. So the balanced equation reads 2H2 plus O2 equals 2H2O. Now we have 4 hydrogen atoms and 2 oxygen atoms on both sides, maintaining the balance. Remember, the key to balancing chemical equations is to adjust coefficients, never subscripts. Balancing chemical equations is a crucial skill in chemistry. But have you ever wondered how we can speed up these chemical reactions? That's where catalysts come in. Imagine being able to speed up a slow process without getting involved in it. Sounds like magic? It's actually the work of catalysts in chemistry. Catalysts are substances that increase the rate of chemical reactions without themselves undergoing any permanent chemical change. They act like backstage managers, orchestrating the reaction without stealing the limelight. Catalysts have a crucial role in speeding up reactions that would otherwise take a long time. Picture a crowded city street during rush hour. The cars represent reactants, and the journey's end symbolizes the products of the reaction. A traffic cop or our catalyst can guide the cars, ensuring a smooth journey and a quicker arrival time. In the real world, catalysts are indispensable. They're used in making everyday products like plastics and fertilizers, and even in our bodies, enzymes, which are biological catalysts, help speed up vital processes like digestion. So catalysts are like the superheroes of chemistry, saving the day by speeding up reactions.